Can SpaceX truly scale Starship flights from about a handful per year to hundreds annually without the whole operation buckling under technical strain, regulatory red tape, or even physics? Well, Elon Musk is confident and says yes. But while his vision for a high-frequency, low-cost launch system has impressive engineering and financial logic, it also asks for an almost absurd level of coordination between manufacturing, rocket science, environmental law, and bureaucratic patience. Now, SpaceX is building a production machine that can spit out skyscraper-sized launch vehicles faster than Boeing can roll out 737s, and hoping they don't explode mid-air or offend too many environmentalists. This is the machine that builds the machines. And to understand why this question matters, let's talk dollars and cents. Space launch costs are traditionally astronomical. By reusing hardware, especially enormous boosters in spacecraft, SpaceX claims it can get the marginal cost of the launch down to between $2 and $5 million. If that's true, it would upend how nations, corporations, and universities think about space. Now imagine sending up telescopes, satellites, or research labs without filing a congressional budget proposal first. Now multiply that by hundreds of launches per year. And then there's the longer-term agenda. Starship isn't just about putting satellites in orbit. SpaceX wants it to carry cargo, crew, and infrastructure to the moon, Mars, and maybe even around Earth like an intercontinental bullet train. If you believe Elon Musk, and SpaceX's goal is about turning humanity into a multi-planetary species, and whether you find that noble or narcissistic, the practical effects could shift not just the space industry, but geopolitics, climate adaptation, strategies, and future colonization ethics. Now let's start with the nuts and bolts though, or more accurately, the stainless steel and the methalox. Starship's propulsion system relies on Raptor engines, a methane liquid oxygen combination that SpaceX insists is cheaper, cleaner, and more forward-thinking than the traditional kerosene or hydrogen-based setups. The Super Heavy booster alone uses 33 Raptor engines, producing 16.7 million pounds of thrust. Now, Starship itself adds another 6. That's 39 high-performance engines per launch vehicle, all of which need to be built, tested, installed, and also not explode. Each engine needs to be reusable. That means no single-use disposable parts like in old space. Producing turbopump systems and combustion chambers with high tolerances and repeatability is incredibly difficult, even with cutting-edge manufacturing. Add in a workforce that must grow fast and stay skilled, it's a lot to juggle. Now about the rocket factory. Stainless steel was chosen because it's relatively cheap, holds up well under extreme temperatures, and doesn't melt if it brushes up against a few orbital micrometeoroids. But welding it into a 400-foot tall launch vehicle takes precision machinery, massive facilities, and a ton of human labor, thousands of people. SpaceX is using a segmented stacking approach, rolling and welding cylindrical sections together like a massive cosmic soda can. And unlike traditional aerospace workflows that iterate slowly and carefully, SpaceX operates on a parallel development model. They build multiple vehicles at once, incorporating lessons from each test into the next batch. On paper, it speeds up learning. In practice, it risks letting systemic flaws propagate across units before they're caught. Think of it as beta testing a software update, except your app is a 120-ton rocket, and a crash doesn't just mean losing data, it means a crater the size of a Walmart parking lot. To launch hundreds of these things a year, SpaceX needs an industrial supply chain that's somewhere between Amazon Prime and Cold War-era military surplus. Each Starship needs mountains of stainless steel, methane, and liquid oxygen, not to mention rare earth materials for electronics, thermal tiles for reentry, and enough avionics to run an air traffic control center. All of this has to be delivered just in time without quality issues and with an eye on costs. They've even carved out a dedicated supply chain manager role to grease the gears. Now, What do you do once your flying skyscrapers are built, though? You test them, often violently recently, and as of March 2025, SpaceX has conducted 8 major flight tests. Some of them have been successful, others ended in rapid, unscheduled disassembly, also known as giant airborne fireballs and rains of metal. And while the booster's vertical landings have shown promise, Starship record is messier. Controlled reentry remains a particular problem. Thermal protection systems and flight software haven't always been up to the job, and these tests are divided into phases. Suborbital flights test basic separation and descent controls. Now, orbital flights will check how well Starship performs beyond Earth's atmosphere. And eventually, SpaceX wants to load this thing with people and cargo. It means life support, interior pressurization, payload integration, and eventually, FAA and NASA certifications. None of that is fast, though, and none of it can be skipped, unless you're comfortable sending astronauts up on a maybe. Much of Starship's operation relies on automation. The craft flies itself from takeoff to reentry to landing. That means the flight software has to make thousands of decisions in real time with no room for major bugs. SpaceX is iterating that code fast, of course, updating systems after nearly every test. But more autonomy means more complexity and more code and more changes for something that go wrong if the machine gets confused midair. If the code isn't absolutely 100% perfect, or if an engineering team pulls a sprint and produces even 10 lines of spaghetti code, or someone makes code that will unintentionally create thousands of lines of code that works subpar, the whole mission is in jeopardy. Now, luckily, SpaceX prides itself on being the home for the best of the best coders in the world. So that's very unlikely to happen. Then there's the matter of where all this action is taking place. Starbase, Texas. SpaceX wants to jump from 5 launches per year to 25 by 2025, and that's at Starbase alone. That requires FAA approval and compliance with a range of environmental regulations. They're not minor hurdles, and the agency's assessment focuses on everything from local wildlife disruption to chemical runoff. For instance, methane combustion produces industrial byproducts that must be managed properly. SpaceX has been working on mitigation strategies, noise buffers, wastewater treatment, and ecosystem monitoring, but the pace of permitting is slower than Musk's ambitions. If the FAA doesn't sign off, SpaceX can't launch. No amount of engineering or posting on X can fix that. So is the dream of hundreds of launches per year even remotely feasible? Let's look at the upside first. If they can mass produce Starships with consistent quality, reusability could slash costs to a few $1 million per launch. Methane as fuel is relatively cheap and has the bonus of being producible on Mars. The development model, while risky, allows SpaceX to learn from failure faster than anyone else in the game. On paper, it's a formula for industry domination, but none of that guarantees success. Coordinating 33 engines with flawless timing, developing a safe and reusable spacecraft, and maintaining production without major defects would be an enormous task for even a national space agency. Add to that a regulatory framework that doesn't move at Silicon Valley speeds, and you've got a lot of room for the wheels to come off. The production goals are ambitious, 25 launches in 2025, leading up to crewed Artemis missions by 2026 or 2027, and eventual Mars colonization attempts in the 2030s. Every milestone is dependent on hardware working, software behaving, permits being granted, and funding continuing. A single failure in any of these columns could delay the whole show. Whether you think SpaceX is on the brink of a new era or skating on the edge of an unsustainable hype machine, one thing's clear. They're going for it. Full throttle, minimum brakes, heavy on the spectacle. But if the aim is to make Earth a multi-planet species, there's no room for half-assing this. It's the future of humanity at stake. Let me know what you think in the comments. Also, leave a like while you're down there. Do you think SpaceX is on the verge of sending us to Mars? Or do you think they're just a few failures away from, well, failure? Let me know down in the comments below. Take care of yourselves and each other, and I'll see you in the next one.